Hello. Well, as you can see, it's working. Why didn't it work last time? Stick with me to find out. Hello, I'm Ed and I'm building an electric car conversion. I've spent a few weeks working on the Toyota Prius inverter and the open inverter board. In the previous episodes I cracked open Prius Gen 3 inverter, I ordered open inverter board, soldered some connectors and even cut a few corners. The challenge I set myself is to build an electric car conversion on the budget. Therefore I was choosing components for my project very carefully. So far I managed to purchase an inverter at a very good price. And now I have my electric motor, aka Toyota Prius gearbox. I can start connecting the motor and trying to get it to spin. Last time when I left you, I couldn't spin the motor and I just kept scratching my head why. What did I do wrong? And I decided to analyze the problem properly and start from the place where I was last time to check whether whether the PWM signal is actually produced and it's delivered to IGBTs. And then my plan was to check the signal on the actual connections which attach to the motor itself. But first I started removing the inverter cover, and I found that effectively in all the excitements when I was first mounting the board and testing PWM signals, I forgot to attach the bolts that actually connect IGBTs to the output that goes to the motor. And effectively whatever I was generating in the board and IGBTs, it actually wasn't delivered to the motor. So after that I carefully assembled everything again and found that it's all started to work. So it's as usual quite a silly mistake on my side and quite a plausible explanation why the motor wasn't working. So now I'll show you what actually went wrong and what did I forget to fit in the connection side of things. Now I'm removing the interlocking cover that gives me access to the cable attachment to the inverter. So the cover is off now and I need to remove the cable connection here. Probably would have been faster with electric driver, but I don't actually have one. And now I can remove the cable itself. And that's the cable removed. Just need to undo the ribbon cable that goes into the open inverter board. And now I can remove the cover. Yeah, basically when I assembled the inverter first time, I put this frame in. So I put all these screws in place and all of these, but I forgot to put these screws. So basically all of the row of those 3 screws and those 3 screws were missing. So it was a bit ironic, but effectively that's where IGBTs are, down there on that bottom board here, and that's how they transfer the signal to these connections. And our motor of course is connected through these 3 connections here. So yeah, that basically what was the problem at the time. Well, now we solved it and we can now run the motor in sine mode. First I'm switching a low voltage power supply which is powering the open inverter board, and now I'm switching the 2 power supplies that provides so-called high voltage, and with a bit of a delay I'm now doing effectively pre-charge, so the current is flowing through the bulb. By switching the switch I will bypass the bulb and then current will flow directly. Now I'm starting open inverter console and selecting AB, which is basically means no encoder, and going to the testing section, which basically I will set up norm to 100 and F slips to 10. And we are spinning. Well, now as our next milestone is achieved, we can rotate the motor in sine mode. So the next step would be to actually work with the FOC firmware. So it's a field rated control firmware, and to do this I will need to wire up the resolver and wire up a pedal, and next step would be to start tuning the motor using FOC firmware. But that will be in the next video. So I will see you then. Thanks for watching. So if you enjoyed the video, please like. If you want to follow up on my videos, please subscribe. So I will see you in the next video.